Hey everyone, and welcome. As a city planner, I am absolutely thrilled to be your guide for this explainer. Today, we're taking a tour through the digital backbone of our future smart city. We're going to break down some massive technological shifts. Think artificial intelligence, big data, and the Internet of Things. But we're looking at them entirely from your perspective as a high school student. We're going to see how these emerging trends aren't just far-off science fiction, but real practical tools that are going to fundamentally shape your daily routine and your future career. Okay, let's kick things off with a quick hands-on experiment. Seriously, if your smartphone is nearby, grab it. Now hold it up and turn it horizontally. What happens? The screen instantly flips to match the orientation of your hands, right? You probably don't even think about it, but that seamless little screen flip is powered by some incredible unseen tech working tirelessly in the background. And that perfectly illustrates our very first concept, smart sensors. Tucked inside your phone are these tiny devices, specifically an accelerometer and a gyroscope. They physically detect the twist of your hand, process that input, and tell your screen to rotate. It's brilliant. These smart sensors are literally the foundational building blocks of all the massive trends we'll be exploring today. They are the eyes and ears of our smart city. So, here's our city tour itinerary for today's explainer. First, morning, home, and commute. Second, midday, school and immersive learning. Third, afternoon, virtual supercomputers. Fourth, evening, blockchain security. And finally, the future, your digital skills. Section 1, morning, home, and commute. Let's start with your morning routine, right from the moment you wake up. You know, traditionally, the appliances in a house just sat there in total isolation. But today, welcome to the Internet of Things, or IoT. Now, everyday devices connect to your home network to actually exchange data. Imagine your microwave, the AC, your smart door locks, and your security cameras all talking and working collaboratively. You can control the whole setup on the go from your phone, creating this incredibly seamless, personal web of things. But as you step out your front door for your commute, the scale gets way bigger. And this is where we see the huge contrast between old legacy infrastructure and modern smart city solutions. Traditional cities are totally reactive. They're blind to a damaged bridge until it breaks, or they only react to traffic after you're stuck in it. Smart cities are proactive. A smart bridge uses wireless IoT sensors to detect microcracks and automatically fires off an SMS alert to engineers to prevent a disaster. Meanwhile, AI algorithms are instantly analyzing live data to perfectly map out the fastest route for your school bus, literally solving daily urban inefficiencies in real time. But here's the catch with all of this. Think about all those city sensors tracking traffic, plus your smart home devices, plus the billions of people online. Together, they generate an astonishing 2.5 quintillion bytes of data every single day. I mean, that is a colossal amount of information, constantly pouring in. Because this big data is way too massive and complex for traditional databases to handle without crashing, we have to approach it differently, using the 5 Vs. We look at volume, which is its enormous size, velocity, the extreme speed it's generated at, variety, meaning everything from structured text to random videos, and veracity, which is asking, hey, can we actually trust this data? If we manage those 4, we can extract the final V, the hidden business value that makes a smart city actually run intelligently. Section 2, midday, school, and immersive learning. All right, so you've made it to school. Let's look at how AI and the cloud are completely transforming the classroom. You've definitely encountered natural language processing, or NLP. It's a branch of AI that bridges the gap between spoken human languages and computers. It's the magic behind the predictive typing on your phone, or voice assistants like Siri and Alexa. But even better, NLP acts as a vital assistive tool. Through speech-to-text and text-to-speech, it helps students with learning disabilities effortlessly engage with their lessons. It's an absolute game-changer for accessibility. Beyond AI, your classrooms are going to feature some wild, immersive experiences. Virtual reality uses headsets to plunge you into a totally computer-simulated 3D world, literally tricking your senses. Augmented reality, on the flip side, takes digital information and superimposes it right over the physical world around you. Schools and industries are using these sensory simulations for things like incredibly realistic flight or driving simulator training. It is completely changing how we learn hands-on skills. Now, you might be wondering, how does your school afford the supercomputers needed to run all this tech? Well, they don't. They use cloud computing. Think of the cloud as renting what you need over the internet. With IaaS, infrastructure as a service, organizations rent the raw remote servers and hardware to build their own networks. But for you, it's all about SaaS, software as a service. That gives you on-demand access to ready-made applications right online. Let's walk through a super relatable step-by-step scenario of this. Say you're writing a group paper. Step 1, you just open your web browser. Step 2, you pull up a collaborative online document like Google Docs or Office 365. Step 3, you and your classmates edit it at the exact same time. And step 4, it magically autosaves directly to remote servers. You are completely leveraging SaaS without ever having to install clunky software on your actual laptop. Section 3, Afternoon, Virtual Supercomputers. So school's out and it's the afternoon. Let's take a peek behind the scenes to see how scientists are tackling massive, complex research problems right now. They use something called grid computing. Instead of dropping millions of dollars on one giant centralized supercomputer, grid computing links up everyday scattered devices, from laptops to standard desktop PCs, over a network. These devices, called nodes, team up temporarily to form a virtual supercomputer. They chop a huge task into subtasks and solve them in parallel. It saves an unbelievable amount of time and money. Section 4, Evening, Blockchain Security. As evening sets in, we really need to talk about privacy. With all these connected networks, what happens if a central city database gets hacked? Enter our security framework, blockchain. Unlike a traditional database held by one person, blockchain is a decentralized, shared database. Here is the step-by-step process. First, a transaction is requested. Second, that request is broadcast to every computer, or node, in the network. Third, all those nodes authenticated together. And fourth, it's securely appended as a new block to an open ledger. Because everyone holds a copy of this ledger, no single hacker can secretly alter the records. It guarantees totally secure, transparent operations for things like voting systems or land registration records. Section 5, The Future, Your Digital Skills. Finally, let's talk about tomorrow. As you prepare to enter this evolving digital economy, the absolute biggest thing you need to grasp is machine learning. This is basically the brain of the smart city. It's a subsystem of AI where algorithms use statistical techniques to actually learn from training data and make predictions on their own, without human coders having to program them step by step. Understanding how these models work and how they are trained is going to be a massive asset for your career. Because honestly, the jobs of tomorrow are evolving fast. You might find yourself in data analytics, using the Python programming language and its pandas library to decode big data. Or maybe you'll dive into robotics and bionics, combining mechanical engineering and computer science to program autonomous search and rescue drones, or even engineer humanoid robots like Sophia, who uses visual data to mimic human facial expressions. Blending these interdisciplinary skills together is going to be your absolute greatest advantage. I want to share a quote with you that perfectly sums up our journey today. The famous computer scientist Edsger Dijkstra once said, "Computer science is no more about computers than astronomy is about telescopes." Think about that. All this incredible technology, the AI, the sensors, the cloud, they are just the telescopes. Ultimately, all of these emerging trends are just tools waiting for your human ingenuity. So as we wrap up our tour of the smart city, I want to leave you with this provocative question. How will you use these tools? What role are you going to play in shaping and designing the intelligent systems of tomorrow? Thanks for hanging out with me for this explainer, and keep exploring.